This is gonna blow your mind. Welcome to Planet Pulse. Here on Planet Pulse we journey beyond the edge of the known and dive deep into the mysteries of the universe. If you're fascinated by the wonders of space, the epic stories of robotic explorers, and the secrets of our cosmic neighborhood, you're in the right place. Here, we unravel the greatest adventures ever launched from Earth, one discovery at a time. So, buckle up and get ready to explore the universe with us. Don't forget to hit that subscribe button and ring the bell so you never miss a voyage into the unknown. The cosmos is calling. Let's answer together. Imagine the edge of our solar system. What do you see? Maybe you picture a cold, dark, and empty void, a silent, frozen frontier where the sun's influence just fades away. For centuries, that was honestly our best guess. But, the universe is almost always more surprising, more complex, and way more wonderful than we can imagine. Our sun doesn't just shine with light, it breathes. It exhales a constant stream of charged particles, a solar wind that travels outward in all directions at about 1,000,000 miles per hour. This wind carves out a vast bubble in interstellar space. We call this bubble the heliosphere. It's our home, our cosmic neighborhood, defined not by planets, but by the reach of our star's breadth. Now, this heliosphere isn't empty space. It's a dynamic, turbulent environment, filled with the sun's plasma. But what happens where this bubble ends, where the sun's wind finally slams into the thin gas and dust drifting between the stars? That boundary is called the heliopause, and it's not the cold, quiet place we once thought. Instead, it's a chaotic, fiery wall. The plasma there, the superheated gas from our sun, piles up and becomes incredibly hot. Think millions of degrees. It's a paradox of the cosmos. The farthest reaches of our solar system, so far from the sun's warmth, actually contain some of its hottest material. It's like a cosmic traffic jam, where our solar system's influence collides with the rest of the Milky Way galaxy. This hot, compressed region is where our sun's magnetic field tangles and interacts with the magnetic fields of interstellar space. It's a place of cosmic conflict and immense energy. Before we sent probes there, we could only theorize about what it would be like. Our models were just educated guesses, mathematical sketches of an unseen frontier. We needed to go there. We needed to send emissaries, robotic explorers with instruments capable of tasting, feeling, and listening to this strange environment. We needed to dip our toes into the vast ocean of interstellar space to really understand the nature of our own cosmic island, our own solar system. And so, we built the Voyagers. These twin spacecraft were humanity's message in a bottle, cast into the cosmic ocean. They were designed to give us our first close-up look at the giant outer planets, Jupiter, Saturn, Uranus, and Neptune. But their journey had a grander, more ambitious final chapter. Their ultimate destiny was to travel beyond the planets, to push through the sun's protective bubble and become the first human-made objects to enter the space between the stars. They were built to answer a fundamental question: where does our home end, and where does the rest of the universe begin? Their odyssey would redefine our understanding of our place in the cosmos. It all began in the summer of 1977. A once-in-a-lifetime alignment of the outer planets made a grand tour possible. Voyager 2 launched first on August 20th, followed by its twin, Voyager 1, on September 5th on a faster, more direct trajectory. They were marvels of engineering for their time, equipped with cameras, sensors, and spectrometers to study everything from planetary rings to magnetic fields. They harnessed the gravity of the giant planets, using a gravity assist technique to slingshot themselves from one world to the next. This cosmic billiards game accelerated them to incredible speeds, putting them on a path that would eventually take them out of the solar system entirely. They gave us breathtaking postcards from Jupiter and Saturn, forever changing how we saw these gas giants. After their planetary encounters, the Voyagers sailed onward into the vast, dark expanse beyond Neptune. For decades they traveled through the outer heliosphere, a region dominated by the sun's solar wind but far from its light. Their instruments continued to measure the environment, sending back data about the thinning plasma and the weakening magnetic field. They were getting closer to the edge. In 2012, after a 35-year journey, Voyager 1's instruments detected a dramatic change. The solar particles that had buffeted it for decades suddenly vanished. At the same time, the probe was hit by a surge of high-energy cosmic rays, particles born in distant supernova explosions and other violent cosmic events. The spacecraft had done it. Voyager 1 had crossed the heliopause. It was now swimming in the medium between the stars. It was the first time any object from Earth had entered interstellar space. Humanity had officially stepped outside its front door. 6 years later, in 2018, Voyager 2 followed its twin. Because its instruments were still measuring the speed, density, temperature, and pressure of the plasma, it was able to give us an even clearer picture of this momentous crossing. It confirmed that the boundary is not a simple, smooth line. It is a complex, turbulent frontier, a place where the sun's influence finally gives way to the galaxy at large. The journeys of these two probes represent one of humanity's greatest explorations. They are an extension of our senses, reaching out across billions of miles to touch the cosmos. Think about it, these machines, built by human hands in the 1970s, are still operating. Still, sending us information from a place no human has ever been. They are our robotic pioneers, charting the unknown territory that lies beyond our planetary system. Their passage into interstellar space was not just a technical achievement, it was a profound moment in our story, the moment we truly became a species of interstellar travelers. Once outside the solar bubble, the Voyagers began to hear a new kind of music. The instruments on Voyager 1 detected a persistent, low-frequency hum. This wasn't sound in the way we experience it, but vibrations in the interstellar plasma, the thin ionized gas that fills the space between stars. It was the background hum of the galaxy itself. Scientists realized they could use these plasma waves to measure the density of the interstellar medium. The findings were honestly astonishing. The space between the stars wasn't a perfect vacuum. It was filled with a plasma that was far denser than what was inside our heliosphere, a gentle but constant pressure from the galaxy pushing back against our sun's bubble. The discoveries didn't stop there. The magnetic field in interstellar space was also a surprise. Our models predicted it would align neatly with the galaxy's own magnetic field. But Voyager's data showed something much more complex. The magnetic field, just outside the heliopause, seemed to be draped over our solar system's bubble, distorted and compressed by the sun's outward pressure. It's as if our heliosphere wears a magnetic cloak, shaped by its journey through the interstellar medium. This discovery forced us to rethink how stellar systems interact with their galactic environments, revealing a dynamic interplay of forces we had never directly observed before. Then, there were the cosmic rays. Inside the heliosphere, our sun's magnetic field acts as a partial shield, deflecting many of these high-energy particles. But once Voyager 1 crossed into interstellar space, it was fully exposed. The number of galactic cosmic rays striking its detectors shot up dramatically. For the first time, we were able to measure the true, unfiltered spectrum of cosmic rays in our galactic neighborhood. These particles are the messengers of the most violent events in the galaxy: exploding stars, black holes, and neutron stars. By studying them directly, we learn about the very fabric of the Milky Way and the powerful engines that shape it. Even the heat was a puzzle. How could the plasma at the edge of the solar system be so incredibly hot, millions of degrees, while the interstellar gas just beyond it was so much cooler? The answer lies in energy and density. The plasma at the heliopause is extremely thin, with very few particles in any given space. So while each individual particle is buzzing with a huge amount of energy, making it hot, there are so few of them that you wouldn't feel any heat at all. It's a cosmic lesson in thermodynamics, showing that temperature and heat are not the same thing. The Voyagers taught us that the universe is full of such beautiful and honestly counterintuitive truths. In late 2023, a crisis emerged from the darkness of deep space. Voyager 1, then more than 15 billion miles from home, suddenly fell silent. Well, not completely silent. It was still transmitting a carrier signal, a steady tone that told us it was alive. But the signal contained no science or engineering data. It was just gibberish, a repeating pattern of ones and zeros that made no sense. For the mission team at NASA's Jet Propulsion Laboratory, it was a heart-stopping moment. Their venerable explorer, a faithful correspondent for nearly half a century, was lost in a digital fog. The challenge was immense. How do you fix a computer when it's a 22-hour radio call away? The engineers became cosmic detectives. They knew the problem was likely in the Flight Data System, or FDS, the computer responsible for packaging the science and engineering data before it's sent to Earth, but they couldn't just reboot it. The commands had to be precise. Sending the wrong instruction could silence the spacecraft forever. They began a painstaking process of elimination, sending commands to the spacecraft and then waiting nearly 2 full days for a response to travel back to Earth. It was a slow, deliberate conversation across the solar system. The team had to pore over decades-old documents and rely on the knowledge of engineers who had designed the system 50 years earlier. The breakthrough came from a clever idea. The team sent a command to Voyager 1 to poke its FDS memory, asking it to send back a full readout of its contents. When the data finally arrived, they found the glitch. A single chip, a tiny portion of the FDS memory, had failed. This corruption was scrambling all the data. The solution was as elegant as it was audacious. They couldn't repair the broken chip, so they would have to work around it. The plan was to surgically slice up the affected code and store it in different locations scattered throughout the FDS memory. It was like finding a new home for your thoughts after a part of your brain has stopped working. In April 2024, after months of work, the team sent the complex software patch across the billions of miles of space, and then they waited. The signal returned, and with it, a stream of clear, legible engineering data. Voyager 1 was talking sense again. A few weeks later, the science instruments came back online, one by one. The spacecraft was back in business, ready to continue its exploration of interstellar space. This incredible feat of long-distance repair was a testament to human ingenuity and our profound connection to these robotic explorers. We had reached across the void and healed our distant child. While the Voyager's interstellar journey is their final chapter, their discoveries along the way rewrote our textbooks. They revealed Jupiter's volcanic moon Io and Saturn's magnificent complex rings. They gave us our first and only close-up views of the ice giants Uranus and Neptune, discovering new moons and bizarre magnetic fields tilted at crazy angles. But one of their most tantalizing discoveries came from Saturn's small, icy moon, Enceladus. Voyager's images showed a surprisingly smooth, bright surface, hinting at recent geological activity. It was a puzzle that would later be solved by the Cassini mission, which followed up on Voyager's initial glimpse and found something extraordinary. Cassini discovered that Enceladus is spraying giant plumes of water vapor into space from deep cracks in its icy shell. It was flying through a salty mist, and that mist contained not just water, but also organic molecules and silica nanoparticles, evidence of hydrothermal vents on the floor of a subsurface ocean. This was a bombshell. Hydrothermal vents on Earth's ocean floors teem with life, independent of sunlight. The discovery on Enceladus means this tiny moon has all the ingredients thought to be necessary for life as we know it. Liquid water, organic chemistry, and a source of energy. Voyager opened the door, and Cassini walked through it, placing Enceladus at the very top of the list of places to search for extraterrestrial life. What's next for the Voyagers? Their plutonium power sources are slowly decaying. In the coming years, engineers will have to turn off their science instruments one by one to conserve energy. Sometime around 2036, they will likely fall completely silent, their long conversation with Earth finally over. But their journey will continue. They are coasting through the Milky Way at over 30,000 miles per hour. In about 40,000 years, Voyager 1 will drift past a star in the constellation Camelopardalis. They are humanity's silent ambassadors, carrying with them a golden record, a time capsule of sounds, images, and music from our world, just in case they are ever found. The Voyager mission is more than a story of science and engineering. It's a story about us. It's about our insatiable curiosity, our desire to see what's over the next hill, even if that hill is billions of miles away. These two small spacecraft, built by one generation, have become a multi-generational quest, connecting us to the grand cosmic narrative. They remind us that we live on a small, fragile world in a vast and wondrous universe, and that the greatest adventures are the ones that take us into the unknown. Their legacy is not just in the data they sent back, but in the inspiration they provide for all who dare to look up and wonder. As our journey with Voyager's cosmic Odyssey comes to a close, we want to thank you for traveling with us across the vast reaches of space and time. If you enjoyed exploring the mysteries of our universe, don't forget to hit that like button, share your thoughts and questions in the comments, and subscribe to join our community of cosmic explorers. Curious for more? Check out our other videos for more deep dives into the wonders of the cosmos. We have so many more adventures waiting for you among the stars. Until next time, keep looking up, keep wondering, and remember, The universe is vast, and our journey has only just begun. Thank you for watching Voyager's Cosmic Odyssey.